Another important series is called the geometric series. That's the sum from k equals 0 to n x to the k, which is 1 plus x squared up to x to the n. This is the finite version of the geometric series. The reason it's called the geometric series is because if you take the ratio of two consecutive terms, so here x divided by 1, you get x, or x squared divided by x. You also get x, or x to the nth divided by x to the n minus 1. You also get x. So the ratio of two consecutive terms is a constant here, which is x. We can sum the finite geometric series using a trick. So the trick is that you take the series and you multiply it by x. So if we multiply this series from k equals 0 to n of x to the k by x, then 1 times x gives us x, and x times x gives us x squared. And x to the n minus 1 times x gives us x to the nth. And then the last term here would be x to the n plus 1. So these two series share all the terms except the first one from the first series and the last one from the second series. So we can subtract the second series from the first series. So here we have a 1 minus x times the series. So if we subtract, we get 1 minus x times the sum from k equals 0 to n of x to the k. We get the first term 1 minus the last term x to the n plus 1. And then we can solve for the finite geometric series. So we get the sum from k equals 0 to n of x to the k is equal to 1 minus x to the n plus 1 divided by 1 minus x. Because this is a finite series, there's no problem of convergence. But if we want to look at the infinite geometric series, we have to worry when the right-hand side converges. So now then we would be worrying when the x raised to the n plus 1 converges as n goes to infinity. Well, that converges as long as the absolute value of x is smaller than 1. So as n goes to infinity, the infinite geometric series, converges as long as the absolute value of x is less than 1. And when that happens, then this x to the n plus 1 goes to 0. So we get the very nice result that the sum from k equals 0 to infinity of x to the k is equal to 1 divided by 1 minus x. Okay? And that is the infinite geometric series. We'll have a lot of use for this later in the course. Let's look at an example. The example x equals 1/2. Okay? Then what does this series look like? This is a series which looks like 1 plus 1/2, right? And then 1/2 squared plus 1/4. A quarter, then 1/2 cubed plus 1/8. And if we look at this series, we start at 1, we add to it 1/2, then we add to it 1/2 of that, so we add to it 1/4. We add to it 1/2 of that, we add to it 1/8. So it looks like we're getting closer and closer to 2, but we're not quite there. We need an infinite number of terms to get there. And we can see that if we just substitute 1/2 here, so that's equal to 1 over 1 minus 1/2. 1 minus 1/2 is just 1/2, so 1 over 1/2, which is exactly equal to 2. So let me summarize. We've determined a formula for the finite geometric series. Sometimes it's useful. But in this course, we're going to be more interested in the infinite geometric series, which we can sum and is equal to 1 divided by 1 minus x. It only converges if the absolute value of x is less than 1. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.